Hello, everyone. I'm very happy to be here with you today, having this keynote in front of you. I hope you will like it. We're going to talk a little bit about what we know, about what we have done, and what we expect to do in terms of containerization and containers, actually. First of all, I'd like to introduce a little bit myself. I'm Anna. I'm a passionate application developer like many of you here. I also love microservices, and I share some of my experiences within the Bucharest software craftsmanship community back in my home country in Romania. And in today's talk, we're going to talk, of course, about what we know and what we experimented, and let's see what we can do in terms of expectations. So a brief history around containerization. Well, containers have been around for since 1970s, when the concept was firstly brought up with Unix systems to better isolate application code. This sounds familiar, right? Also with microservices concept. While useful in certain application development and deployment scenarios, the containers back then had the drawback that they were not portable. And nowadays, we know that portability is a key thing when we're working with microservices, and not only. Well, nevertheless, a lot of people have worked and invested a lot of time bringing forth extraction capabilities to make the enterprise IT more flexible and containers evolve. And thanks to the rise of Docker containers, it's now possible to easily move workloads between different versions of Linux and clouds and everything else, and have multiple containers to choose from for our microservice architectures and so on. By the way, this slide is my point of view regarding the evolution of containers. I know there are a lot of events in the evolution of containers, but it would be a very, very, very long timeline, and it wouldn't fit in this slide. We love containers. The reason because of so much innovation around containers happened and still happens nowadays is because we got a taste of instant boot, of modularity and portability. What I mean by instant boot is the fact that, well, applications use the same OS, thus overcoming the delay of booting up. Well, some of you think, well, we had that also with VMs. What changed? Well, the thing is that we are using the same image, the same base. We're not having multiple base all the times, and we're duplicating our OS all the time. When I say modular, of course, I mean microservices. And of course, we like that nowadays when we're building a container, we're using that, we're building that image, and we're using that across all our environments. So we can download that from registry, and we're making it portable, right? One question for you. I know it's pretty early. I'm also a little bit sleepy and a little bit having a cold. I want to ask you, do you love containers? Please raise your hands if you love containers. Okay? Lots of love for containers in this room. This is good. Do you love to experiment with containers? Not as many hands? Really? Okay. So, well, let me ask you this. What principles do you use when you're building a container? When you're building a Docker image, for example, what do you think of when you're building with that? Or just say anything that comes to your mind. Order of commands, of instructions, right? Okay. Size, good. Okay. Okay. Yes, that's a very good one. Yeah. So we know a lot of principles when we're building a software product, right? We know. We also know those principles that are not so much principles, like dry, like don't repeat yourself, like KISS, keep it simple, you aren't going to need it, and so on. These are more like jargon expressions. These are not necessarily principles. However, even if these principles do not specify concrete rules, they represent a language, a common language for us developers to orient ourselves. And when we're talking to a colleague, we're kind of telling him, well, keep it simple, right? Or don't repeat yourself, or maybe you aren't going to need this. Same applies to containers. So this is extracted from a Red Hat white paper. It's published online. It's available for everyone to read more about it. There are some principles for you to think about when you're building a container or you're building a Docker image. There's a single concern principle, meaning that your container should do one thing and do it well. Kind of like the microservices. They should be concerned of doing one thing well. Then there's the self-containment principle that, well, container should be able to, be confined and have a set of predefined rules when it's going to be evolving within. Then there's the image immutability principle, meaning you've built an image and you're going to reuse that image across your environments. You're not going to rebuild it on QA or on other environments. You're going to have different configurations, but those are coming to you from the infrastructure, from the orchestrator. You don't need to confine those configurations in your images. You're just preoccupied of having that stateless, beautiful application and receiving configurations from outside of that containerized app. Of course, there are also container runtime principles. So you want to be able to observe what happens with your application. And the high observability principle from the same paper, it speaks about the fact that you should be able to provide from your application the way that your application can be observable by the environment, meaning you are providing the health checks, you are providing the endpoint for the metrics, or for a way to see how your application is evolving. Also, your application should have a lifecycle conformance, meaning your application should be able to receive information from outside the platform and to react to those informations that are coming from within the platform. There's also the process responsibility principle. Well, we all know that containers can also die, so you want to be able to rapidly spin up another container and not to feel sorry that your container died or that you've lost information. And last but not least, the runtime confinement principle that talks about the fact that your containers should have an amount of resources and requests predefined, and you should evolve your application having those in mind, meaning that you've built your application, but it shouldn't have like a spike later on in time in terms of resources used and in terms of requests that it does. Those being said, with these principles in hand, the road to success is starting. So the road to success for every microservices-based project, well, you're building applications, very nice applications, you're putting them in Docker containers, all is very nice and great. And somebody mentioned earlier about Docker images. Well, yeah, everyone here, I'm assuming, that knows to build Docker file. If you don't know it, of course, everyone can Google that. And of course, yes, layers are very important for Docker images and for containers in general, because layers are the ones that are giving us and are influencing a lot the size of our image. And we should think of the layers in terms of how frequently we update them. This is very, very important. However, not a lot of people think about layers this way when building a Docker image, or they don't build a Docker image thinking about how many layers it's going to generate behind the scenes and how important is that going to be for them. So this is why sometimes you get to this kind of situation. Well, if it fits in a Docker image, why don't put it in a Docker image? Because we're always thinking like cloud native and everything should be there in a container. Well, we were brought this Kubernetes orchestrator, and we should reuse it at maximum for everything. So we should Dockerize everything, given that we get sometimes a lion in a cartwheel running there in the container, consuming a lot of resources, or sometimes even growing and asking for more, demanding for more. But it fits in a Docker image. You can Dockerize it. You can put it there. It runs. I mean, it's a great success when it runs. You see it runs, yeah. You can access an URL from that application. But in the end, well, yes, all containers are the same, all cats are the same, but they're not necessarily normality, right? So I read like 2 years ago an article on Medium about a team that was complaining that Docker is not good enough for them because they were pushing containers, and actually they were pushing images of 2 gigabytes. And this is why Docker is not good for them. But their point of view. However, you get to this amazing app in your registry of 2.3 gigabytes or 2 gigabytes or more when you are not paying attention to a few things. However, if you're having this challenge in your experiments of big Docker images and you get to 2.3 gigabytes with your awesome microservice, of course, there's some ways on putting it to diet. So the way to put to diet a Docker image is, firstly, I think lightweight official images. Yes, everyone knows that about base images, small base images, Alpine Linux, CentOS, I don't know, every small distribution of Ubuntu or whatever you find on the internet. But another thing to be known is don't install packages that you don't need. What do I mean by that? Sometimes when we're experimenting, we are, like when we're coding an application, we're putting that package, that library over there. To experiment with it, we forget that we put that over there, and we grow. But we kind of don't come back and take out that package over there. So it's not that common to come back and clean up after you. Sometimes you can get even from the base image maintainers some information about what packages you can get out from your base image safely and use it in a lighter manner. And pay attention to those. Third one, well, as discussed earlier about layers. Well, put instructions that are likely to change lower in your Docker file. What I mean by that is that Docker is very awesome because it works with caching to help you more quickly build your images. And what it does when building an image, Docker steps into the instructions, those instructions you have over there, executing each of those in order. As each instruction is examined, it looks for an intermediate image that was already there in the cache. If it can find something that can be reused, then it gets that intermediate image and it uses it. It doesn't build another one. Now, the thing with this one is that if your instruction is the one that is going to change and you put it in the middle of your Docker file, but the next ones that you are having afterwards are like the same, and you could have used the caching, what we'll do, every instruction that follows after the one that was invalidated and builds a new intermediate image, it's going to be taken into account. So this is why put lower in your Docker file the instructions that are likely to change, that are that are likely to change. And thirdly, actually fourthly, the Docker ignore file. Well, the Docker ignore file is very useful when you're building your application. I mean, we know that in the code repository we're putting our application code, but sometimes we're also putting some scripts that are useful in the pipeline because, well, they belong to that small microservice and we're using with that context over there. But they don't necessarily mean something for the containerized application that we're having. So this is why Docker ignore file is helpful. You can extract from the image itself and put there only what you need for your inside to run correctly. So Docker ignore is kind of like git ignore, but for Docker. This is the definition shortly. Also, there's some bonus around it. Using multi-stage builds in the experiment. So you can also try using multi-stage builds, like making a build and the second multiple froms. From the first from and from the result of the first build, you're extracting only what you need. So for example, in this case, I don't need everything that was the resulted on the previous nvn clean package. I only need the jar file. So I'm just going to copy that one and use that one in my final containerized image. And last but not least, because we were talking about layers, employ the double-end command separators. So the command separators are not very often used, but what's very neat about them is that when you're doing this kind of joining, this kind of join of commands, you're kind of renouncing two layers. So instead of specifying run, 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 you're just having one layer generated by this run. And this is a way to have less layers in your Docker image. Next, is it safe enough to run containerized images? A lot of people think about Docker and Docker images and actually containers in general, like that thing that I built over there, it's never going to be required to have updates. I never need to patch it, and yeah, it's never going to be my problem ever again because it's containerized. So why should I be bothered about that? So that's a wrong approach when it comes to security and Docker containers. And a lot of, well, organizations might have had problems because of that, because they thought that, well, we built it once, it's there, we never need to touch it again. Nowadays we have, well, with these beautiful code scanners, and we have also vulnerability scanners for our Docker images. And it sometimes happens while the image that you build in the morning, well, later in the evening has like, well, lucky you have one issue, or two issues, or three issues. These kind of, please pay attention to these code scans and these image scans, because they kind of tell you that you're vulnerable, that you need to rebuild your Docker image, or you need to patch your Docker image to make sure that you are safe against any vulnerability outside the environment. However, there are some things that are never getting old when it comes to Docker and containers. One of them is using Docker containers with Linux enabled. This means that it prevents processes inside the container from overwriting the host Docker run C library. Also, there was I think in February 2019, there was a vulnerability that was pretty big and was pretty popularized. If you would have had this minus Linux enabled, also read-only file system on the host and a low-privileged user inside the container, you would have not needed to make the update and make some patches for that vulnerability. So sometimes using these basic things that are already there for you in Docker for some time ago, it makes you, you know, not invest in as much as effort as later on in the in time when the vulnerability arrives. So there are some best practices that never get old. Also, when you're thinking about orchestrators, and here's the case of Kubernetes, a good thing about, you know, elevating the security is setting the security context. And for the deployment and or for the pod, because you can set the security context also at pod level. And of course, set the file system to read only. You don't need to write most of the time. So why write and give abilities of root to your container orchestrator or to or for the insides of your Docker image if you don't need that? So try to be as restrictive as possible, or minimum restriction applied to your containers. I think I've dived a little bit into Kubernetes a little bit, and we're going into the dragon's mouth with this one. But Kubernetes and actually container orchestrators have a few basic rules for us to think about. So in terms of resource management with orchestrators, we're kind of evolving between three dimensions, and those are CPU, memory, and ephemeral storage. These are the three that we're always going to be in our mind when we're working with orchestrators. So for this, we're going to just quickly go through these. For resource management, you're always going to think and have a picture in your head about, okay, how am I going to limit the amount of resources that I'm using, the requests that I'm receiving, and so on. This is called establishing soft and hard limits with resources in the orchestrator. And it's good to have them because nothing is infinite, even with containers and even with orchestrators. Everything costs money, after all. Also, health checks to indicate that our application is feeling good. There's always good to have those. And of course, it's always nice to have affinities and anti-affinities set for our pods, because this helps the scheduler to know how to orchestrate the workloads in a better way for your application. Not a lot of people are working with affinities and anti-affinities at node and pod level, but I can assure you that it helps you in identifying the policies when working with containers, with workloads, and when you're having a lot of microservices to manage. Deployment strategies. I think all of us, when they hear about containers, about Kubernetes, about container orchestrator in general, are thinking like how we're going to deploy it. Well, there are deployment strategies coming by default with Kubernetes. There are also deployment strategies that you can make on your own based on your needs. Also, the pod disruption budget, another thing that's not very often used. This pod disruption budget is the type of object that helps you into maintaining a minimum available set of pods. So it's like a reassurance for the workload that you're having that makes sure that you're still having something to run. So a type of object that is kind of there for you in terms of, let's say, recovery. And last but not least, high availability, disaster recovery, and scalability. These are a few things to think about when you're thinking about resource management at the orchestrator level. So high availability in terms of experimentation with Kubernetes, we're always going to have replica sets that are going to ensure for us that we're having something available over there. And of course, we can employ the horizontal pod auto-scaling policy in Kubernetes to make sure that we're not manually scaling workload when we're seeing an increase of workload for a certain microservice. For disaster recovery, well, that's more like a long-term plan, and it's like planning across multiple data centers, probably, or multiple regions for your application. But these two managed together, I mean, the horizontal pod autoscaler, it works wonderful and does a lot of good stuff for us for our stateless apps, because if you're having stateful apps, and I know that in terms of microservices, we're thinking most of the time of stateless apps because persistence, it's stored outside it. It's the best practice, and we're thinking all the time of 12 factors. But however, in time, some people needed also a way to manage the amount of memory or the CPU usage that and a containerized application was using. So this is why the vertical pod autoscaler came into the picture. The vertical pod autoscaler is there, exists over there, can be used. However, there's a catch. For the same application, for the same microservice, you cannot use vertical pod autoscaler and horizontal pod autoscaler at the same time. Makes sense, right? You cannot vertically and horizontally scale at the same time. Then you should make sure that you're not overusing those two, and of course make a lot of tests that those are not interfering with each other and generating some unwanted behavior. And since we're talking about tests, documentation in testing is another experiment that happens nowadays in a lot of teams. I think that documentation is sometimes something that we don't like to do as developers. We never like that when we get to that area. However, when it comes to documentation, and I'm going to talk a little bit about these in my Helm session, so this is a kind of connection to my Helm session. Well, for testing, set up liveness and readiness probes, because these probes help you into firstly testing that your application is ready to receive requests and then is healthy enough to work as you want it. Secondly, if you're working with Helm, you have this notes.txt. Well, that's the documentation that you need. You can put there your own instructions for the person that uses that those charts, or Helm charts, to make sure that they're using it properly, or to have like a hint on what port or on what IP or whatever address you're using over there, to know where they can find what they have deployed using those charts of yours. There's also linting, testing, and of course hooks. And also, I'm not talking here about Helm hooks just in terms of, this is in the context of Helm, but you can implement also hooks not just with Helm. So most of the time, when it comes to testing and testing regarding containers, it's not the traditional unit testing that we're kind of used to. It's more like integration testing and end-to-end testing. Last but not least, I want to tell you a little bit that, when talking with my colleagues, I all the time hear that, this Kubernetes thing was not built for developers. This is true. Or it's not built for normal app developers, because we know our languages, and we need to adapt to a different paradigm when using Kubernetes. However, if you want to learn a bit more about Kubernetes, it's not impossible. And you should be, as an app developer, you should at least have a hint of idea of what your DevOps colleague is doing over there, because this is how you can do DevOps. Know a little bit on what you're doing together with your colleague, and this is how I work with my colleagues, because if I don't know what he or she does, it would be more difficult for me to explain what I want over there, and same applies from their side. So this is how you can build DevOps, actually, by knowing a little bit on what's happening over there. In terms of expectations, we see that initiatives like KEYNOTE or OpenFast with serverless functions are coming for us, for developers, to make Kubernetes much more familiar, to make this gap of understanding and adapting to the world of containerization something that we can touch. That's not like, oh, this represents a total different area. It's not my expertise. It's not my bucket. I'm not going to be interested. I'm not going to have an interest on this because I don't know this new language, this new paradigm. It's just that we need to be a little bit more open. We need to experiment more. And of course, there are a lot of experiences all over the web from which we can learn. So, those being said, I want to thank you for listening to me. I hope you come to my session about Helm today and talk a little bit more there. And prepare your questions for today, for the debate tonight, because I'm really hoping to have an interesting debate and get some more of the microservices architecture. This type of architecture has been around for quite some years, has been advertised a lot, but we're always getting much more good stuff when we're talking, when we're debating, and we're sharing our own problems and our own solutions. Don't need to disclose anything, from work, but I'm sure you can ask your questions and find a way around those. Thank you.